We're given a trapezium with the top and the bottom sides parallel, but also UT is parallel to those two. And we're told that the top one is 3, the bottom one is 12, and we're asked to work out UT. Now this question is all about similar triangles. I'm going to go for it in two different ways, both of which are going to use the fact that this blue triangle and this red triangle are similar. Then my methods will slightly deviate. So the reason we know they're similar is because of the parallel lines. So those two are alternate, they're the same, and the same goes for this one and this one. And these two are vertically opposite. So there we go. All the angles in the triangles are the same, and therefore they are similar. Now, if I was to rotate this blue one to make it look like this, then you can see the scale factor is these two sides, the 3 and the 12, that's the corresponding sides. So my scale factor is 4. I'm timesing through by 4. Okay, here we go. Here's method 1. So that tells me that the height of the red triangle is 4 times the height of the blue triangle, but it also then follows that this length here, where I'm going some direction up from the bottom of the triangle to the top of it, must be 4 times this one. So this is x, then this is 4x. But more importantly now, I can say that the whole thing is going to be 5x. And I can focus on a couple of other similar triangles. This one here in black and this one here in black must also be similar. They share an angle down here. These two are corresponding angles, and then the others must be equal as well. And because I know that, well, okay, let me draw them out. So I've got this like large triangle and I've got this smaller one. So I know that this is 3 in length and this is 5x and this is 4x. So what that tells me is my scale factor is 4 over 5 or 0.8. And therefore 3 times 0.8 gives me 2.4. This here is 2.4. Exactly the same argument applies over here with this triangle and this triangle. And it follows that this one here is also 2.4, and therefore the length is going to be 4.8. Nice. So now for my approach involving area, still going to use the same results that the bottom triangle is 4 times the top triangle. This time I'm going to use the height. I'm going to say that this is for h and this is h. And I'm going to call ut, let's call it y. So I can find the area of the whole trapezium. It would be a half times 3 plus 12 multiplied by 5h. Half a plus b times the height. But that must equal separately this trapezium, which is then a half 3 plus y times h, plus the bottom trapezium, which is a half 12 plus y times 4h. I've created an equation involving, well, h and y, but actually h is now going to cancel out. I can also times 3 by 2 to get rid of the halves. So that leaves me with 15 times 5, which is 75, equals 3 plus y plus 48 plus 4y, which will give me 5y plus 51. Now for 5y will equal 24 and y will equal 4.8. So nice approach there as well. Well done.